When should you use the word percent and when should you use the word percentage? In English, the answer isn't necessarily 100% clear. The word usages are changing over time, and in context, you may see these used interchangeably sometimes. For our purposes and in a mathematical context, though, it does make a difference. So at least for this textbook, you can assume that when you see a change or a difference expressed in percentage points, that's indicating an absolute change, right? If you see the percent sign or the word percent, that's referring to a relative change, right? Now, technically, that's the way the word should be used, even in news articles or informational brochures or things like that, but you may not always see that in real life, right? So it can be confusing, but you need to be aware at least that there is a difference between the two words, and then try to figure out from context how those words are being used. All right, so here's an example. Let's say that a mortgage interest rate increases from 3% to 4%. Right, so the things that we're actually comparing here are percentages themselves. And what we can't do here is to say that the interest rate increased by 1%. Right, so that would be kind of confusing. Or maybe misleading is a better word, maybe unintentionally so. It would be correct, however, if we're talking about the absolute change, right, just 4% minus 3%, or the difference between these, right, it would be correct to say that this increased by 1 percentage point. Right? But if we want to talk about the percent increase, that's the relative change. Right, so we want to take the absolute change, which is 1 percentage point, and we want to divide that, okay, by the reference number, which is 3%, right, and then multiply that by 100% to turn that into a percentage. Okay, so that's actually 33 1/3%, right, or we could round to 33%, right. So it's correct to say that the interest rate increased by 1 percentage point, or it increased by 33%. Here's another example. According to Pew Research Center polls, the percentage of adults who regularly read a daily newspaper fell from about 54% in 2004 to about 38% in 2017. Okay, let's describe this change in two different ways. All right, so first of all, the absolute change. Right, we can talk about an absolute change in terms of percentage points. So that would be 54 minus 38. Right? And then let's write this out in words. That's the textbook's preference, at least, to be clear about the fact that this is an absolute change. Right? So this would be a decrease of 16. Actually, sorry, let's reverse those. Okay, the 38 is the new value, and 54 is the reference. Okay, so now we're going to get a negative number, which was reflecting a decrease. Right, so that's a decrease of 16 percentage points. All right, and then how about the relative change? So let's compare that absolute change of 16 percentage points back to the reference number, which is 54%. And then we'll multiply by 100%. Right, and that's going to be about negative 30%. Right, so we can say that the percentage dropped by 16 percentage points, or we can say it decreased by 30%. All right, and one more example. Assume that 40% of the registered voters in Carson City are Republicans. Read the following questions carefully, then give the most appropriate answers. The percentage of voters registered as Republicans is 25% higher in Freetown than in Carson City. What percentage of the registered voters in Freetown are Republicans? Okay, so we can assume that because we see 25% written with the percent sign, that we are talking about a relative change here. So we're comparing Freetown back to Carson City, right? So Carson City is the reference value, right? So to find the relative change, we want to take 25% of Carson City, which is 40%. All right, and we can work with maybe decimals here, so this would be 0.25 times 0.40, which is 0.10, right, which is 10%. Right? So that's the relative difference. So we're going to start with Carson City, which was 40%, and then add the relative difference, which is 10%, and then that gives us 50%, which is the percentage of registered voters in Freetown. All right. On the other hand, let's say the wording in Part B here, let's say that it was the percentage of voters registered as Republicans is 25 percentage points higher in Freetown than in Carson City. So there, that would be talking about an absolute difference. All right, so we'd have the Carson City number plus the absolute difference of 25 percentage points, and that should give us the Freetown number. All right, so Carson City was 40%, okay, plus 25%, which would give us 65% for Freetown. Let's also talk about solving percentage problems. And let's continue to use the three-step process of understanding the problem, solving it, and then explaining it. All right, so here are some general suggestions to understand the problem. Try to write it as a complete sentence and use some of these key words like is, of, more than, less than, and rate. And then start by making an equation, and that would give you a way to be able to solve the problem. All right, and then at the end you can go back and explain and see if it makes sense in context, and also be sure to be clear in your words, you know, whether you're talking about a percent versus a percentage, what things are the reference values and what things are the compared values. All right, so you want to write a sentence using some of these words because they do have mathematical symbols that are associated, and as a summary, we've talked about, I think, all of these at this point. But the word is indicates equals, right? The word of indicates multiplication, more than indicates addition, less than indicates subtraction, and then the word rate often indicates some sort of a percentage. All right, so we could talk about a tax rate or a commission rate, something like that. As another tip, right, your textbook gives you a few specific equations, right? If you know that some value is a certain percentage more than, right, then this gives you an equation that you can jump straight to if you prefer. Right? So let's say that you have a final or a compared value, and you know that it's p% more than some sort of an initial value. Right? So you can convert this to an of statement, which does make it easier to solve. Right? So the equation would be that the final value is 100 p% of the initial value. All right, so if something is 30% more, right, then that means that the final value is 130% of whatever the initial was. Right, and then from there, that makes it a little bit easier to solve. So let's try an example. So let's say in part A of example 10, you purchase a t-shirt with a labeled pre-tax price of $17. The local sales tax rate is 5%. Right? What is your final cost, including tax? All right, so to help understand this problem, let's try to write this as a sentence, and again, let's keep in mind some of those key words. Right, so we're trying to find the final cost, including tax. Right, so the final cost, well, what is that? Well, that's the like the sticker price, right? The labeled price. Okay, plus the tax. Okay, and then we can start filling in symbols and numbers here. All right, so the final cost is unknown. So let's call that I'll call that F for final cost. Maybe you like X or something like that. Or you can write final cost if you just prefer to have it written out in words. Right, is means equals. The labeled price, well, we know that that was $17. Right, and then plus tax, so we need to add in the tax. Right, well, what is the tax? The tax is 5% of the pre-tax price. Right, and of means multiply, so we need 5% of $17. Right, or times $17. And then this gives us an equation to solve. Right, so the unknown is by itself, so we really just need to do the arithmetic on the right side of the equation to figure out the final cost. Right, so you may remember order of operations. We need to do multiplication before addition. All right, so 5% of 17 is 85 cents. Okay, and then the final cost is $17.85. In Part B, your receipt shows that you paid $19.26 for a phone case, tax included. The local sales tax rate is 7%. What was the labeled pre-tax price of the case? All right, so let's use this equation from the textbook that the final value is 100% of the initial value, where P stands for the percent more than or less than. All right, so we know that the pre-tax price, let's start with final. Okay, the final price is equal to 100 and P% of the pre-tax price. Right, and then the P here is 7%. Okay, because the final price is 7% more than the pre-tax price. Right, so final is 107% of pre-tax price. All right, so in this case, we know the final price, $19.26, and it's the pre-tax price that we don't know. All right, now I'm going to convert 107% to a decimal, so I'm going to write 1.07, right? And then I'm using P here for the pre-tax price. All right, so to solve this, we need to divide both sides of the equation by 1.07. And then we get the pre-tax price, which is $18. All right, and then just a quick check to explain this and see if it makes sense. The pre-tax price should be lower than the price with tax included, and it is, so that seems to make sense. In Part C, you are eligible for a 15% student discount for basketball tickets that otherwise cost $55. How much will you pay? Right. So let's write a sentence to understand this. So the student price is 15% less than the normal price. Less than normal price. Okay. So if we convert that to a percentage of, all right, remember the little equation 100 minus P%. Okay, so if it's 15% less than the normal price, that would be 100 minus 15, or we could also say that the student price is 85% of the normal price. $85 of the normal price. Okay, so we have a sentence, and then let's make this into an equation. So the student price is unknown, so we'll call that S. Is means equals. 85%, let's write that as 0.85. Of means multiply, and then the normal price is $55. So the student price, multiplying those two things, is $46.75. All right, so we've understood it, we've solved it, and then to explain it, you might want to just write a sentence. The student price is $46.75. You could even say which is 85% of the normal price of $55. Okay, and that makes sense. It is it is less than 55, so you're probably on the right track. For our final example, we'll consider the statement from the beginning of the unit, which was that the rate of e-cigarette usage among middle school students was up 36% to 5.3%. Right? And our goal is to figure out the rate of e-cigarette usage among middle school students before this rise. So the two numbers that we have are this 36% and this 5.3%. Right? So the 5.3%, this gives us a current rate of e-cigarette usage. Right? So we have the current rate, right? And then that is up 36% from what it was before. Right? So this 36%, that's a relative amount, so that's describing an increase or a more than amount. So we could say that the current rate is 36% more than the original or the reference rate. Okay, and our goal is to find that reference rate, okay, the amount before that rise. All right, so let's turn this into an equation, and again, let's use that tip. If it's up by 36%, or if it's 36% more than, then we know that it's 100 plus 36% of the reference rate. Okay, so I'm going to replace this with 136%, and we can say that the current rate is 136% of the old rate. Okay, so the current rate, let's start filling in what we know. The current rate is 5.3%. Is means equals, okay, 136% of, so that means multiply the reference rate, and that's unknown. Okay, I'll call this x this time. Right. So to solve, we can divide both sides of the equation by 136%. Okay, and that will solve and give us x. All right, now the percent signs will cancel here. And when you divide 5.3 divided by 136, you get 0.03897 ... It continues. Okay. Now it would make more sense since we're comparing with a rate that was given to us as a percent. Let's turn this into a percent as well. All right, so moving the decimal 2 places to the right, this is about 3.9%. Okay, and then that just looks a little bit more similar to the 5.3%. All right, and then looking back, we knew that the rate went up to 5.3%. Our answer is a little bit smaller than that, so that seems to make sense.